All right, guys. Welcome to today's lesson. We are talking about potential energy today. Now, potential energy is just as it sounds. The definition of potential energy is stored energy. That means the energy is built up, it's contained inside, and it's not going anywhere. It's locked up right where it's at, ready to be released out into the world to do something, to do work. But we always have to have stored energy to do that. I want you to think of potential energy as stored energy. It's like a battery. You've got it right here in your hand. Is it doing anything? No, but it has the potential to do something. You hook some wires up to it and a light comes on. That's what potential energy is. The one we're going to talk about today is called gravitational potential energy. Now, gravitational potential energy is based on the height of an object. For instance, this ball is not moving. Because it's not moving, it has potential energy. So if we have potential energy, and we know it'll do something, because if I let go of it, it's going to fall to the ground and it can break something, it can bounce off something, it can move something. That means there's energy stored right here. That energy being stored here can be released when you drop it. So the object has potential to do something, and that's what potential energy is. So if we jump over to the Jamboard here, we can see that potential energy, and if I write this out, potential energy is reliant upon, well, let's see. The heavier an object, do you think it's going to do more damage than a light object? Well, if you think that a heavy object's going to hurt worse if you were to drop it on your foot, then potential energy must have mass as part of its formula. Now, what about height? If I drop something really close to the ground or I drop something really far away from the ground, which one's going to do more work? Which one's going to hurt worse? If I drop it a half inch from your hand, or if I drop something 10 feet from your hand? Well, we know that the higher it is, the more it's going to hurt. So potential energy is also dependent on height. So now we have mass and height. So the question is, what causes them to fall? What gives them their energy, their force, their impact? Well, that's simple. If an object is falling, it's gravity that's doing all the work. Now, so that means these three things help us calculate what potential energy is. All right, so when we talk about height being a piece that's going to determine how much energy something has, I want to ask you a simple question. I've got this wonderful book here, right? And if I hold it over your hand and I drop it from this height, not going to hurt very much, right? But if I take this book and I drop it from this height, you can hear the difference. That difference is the energy. We can also do the same thing for mass. Which one would you rather have drop on your hand from up here? The book or the sheet of paper? Well, we know we want the sheet of paper because the book weighs more. And that's what affects potential energy. Height, mass, and it's all activated by gravity. Potential energy is given the symbol, a capital P with a little e, symbolizing potential energy. And that's going to be equal to the mass of the object times the height of the object times gravity. Well, what does that look like? Well, I weigh 10 kilograms and I am 1 meter tall. And, oh gee, what is gravity? Well, gravity is a constant. Gravity is always 9.8 meters per second squared. So to figure this one out, if I have a 10 kilogram object that's 1 meter off the ground, and gravity is 9.8, 9.8 times 1 is 9.8. right? 9.8 times 1 is 9.8. And you multiply that by 10, you get an answer of 98. Ooh, what is potential energy in? Well, energy is always given in joules. So you have 98 joules of energy. So when it hits your foot, if I let go of it and it drops and hits your foot, it's going to hit with a force of 98 joules, or it has the energy of 98 joules. That's what potential energy is. So when we get to looking at your lab, you are going to be looking at a lab today. And one of the things we're talking about, the question is, how does height affect potential energy? So you're going to be investigating that in your lab today. Please read the instructions and follow everything in the instructions word for word. It will tell you exactly what to do, and it will get you to solving all the problems with inside the lab piece. Of course, if you have any questions, come talk to me about them or send me an email. Those of you who are in class on this one will be doing this lab in class so that you can work with friends and get it taken care of. See you tomorrow. Take care. Stay out of trouble.